So this graphic on the left-hand side here, we can use to help explain the setup of our digital analog to digital converter. All right, our data acquisition system. So some of the critical components are the interfacial components. So we have inputs, both analog, all right, and digital inputs. We also have digital outputs typically, all right, and we typically also have analog outputs as well. All right. Then we have the internal components of our digital um, our data acquisition system. All right, which we typically have here. All right, so this includes a lot of different things. All right, um, but for the most part, you just need to know that it takes the companies basically do a really good job of taking care of all this information. So you don't really know how all these things work, but you just need to know that basically this is the stuff that these electronics connect with your analog inputs, your digital inputs and outputs, and your analog outputs. Okay, and then uh, typically you set up your system using a computer, right? Where that computer then will will set up the data acquisition system with the parameters that you want to read in your signals and to send out your signals. Okay, so basically you have your computer, you have your data acquisition system, um, all right, and then you have your sensors and processes, right? So you have your sensors, all right, and then you have maybe some other processes that you're trying to control using a analog signal or a digital signal. Okay, so that kind of explains how this whole system is set up. All right, so typically our data acquisition modules. So these are some examples. All right, this is the board that you all have. This is the NI 6001, and then this is an alternate version of that board of a National Instruments an NI board that uses is called a MyRio, and that is kind of neat because you can actually transmit data wirelessly over Wi-Fi. But most devices typically are still wired and connected to one another. And then most data acquisition devices have either signal-ended conditions or differential-ended conditions. So a signal-ended condition, basically the lower level into your signal conditioner is at the ground level, and the high level is the one that you're measuring. While a differential connection actually has two wires connect to the data acquisition board, and we measure the difference between those two voltage. Okay, so typically, all right, differential signals are preferred when possible because it's less likely to suffer from ground loops, which can alter the value of your signal. So you typically have increased accuracy. Downside is that you have more wires, right? And then signals are preferred if your outputs are all relative to the same ground, and sometimes you can design your systems to be that way, so it's not always impossible to do. And because you basically aren't measuring two signals, you're only measuring one. Typically, it improves how many signals that you can read. So you can typically measure twice as many signals, right? So there's some benefits of doing that. It's a little bit more economical. Okay. So there are some data acquisition devices. They have special signal conditioning modules that allow them to read different types of sensors. All right. So for example, there's some that are made to measure strain gauges and thermocouples. Right. So the ones like, for example, the one that we have in the lab is we have the Keysight DAC, and the Keysight DAC is great for measuring things like strain gauges and thermocouples because it has the capability of measuring those very small voltage signals that are common for those two devices. So some devices like the 6000 USB 6001 isn't great for measuring strain gauges and thermocouples directly because it doesn't have those specific electronics that are necessary. So when you're buying a data acquisition system, one of the things that's very critical is to think about what types of signals am I measuring, and is there any way I can buy something straight from the manufacturer of the data acquisition system, a module, so that I don't have to do any additional electronics work, so I don't have to build my own amplifiers or do anything like that. So ideally, you can just plug in your sensors directly to the data acquisition system, and the data acquisition system has all the signal conditioning already built in. Okay, right. And so here's some names of some common companies that are used. Uh, so um, one for data acquisition systems, we have National Instruments, we have Keysight, Analog Devices, Digilent, Analog Discovery, and Measurement Computing. All of these are good. These are all good companies to use. Typically, it depends on what industry you're working in. They might use different ones, and that's okay. The major principles between all the different boards are the same. You just have to read up about the specifications of each. But um, uh, these are all these companies sell different devices, and depending on the application, some of them might be good for you. Some companies might be better than others for your application. But it helps to be aware of where to look before you buy a data acquisition system.